Ethernet bridging process. An Ethernet bridge connects two separate network segments, LANs, to act as a single, larger network, intelligently forwarding data based on MAC addresses to reduce congestion, unlike simple repeaters. It operates at layer 2, data link layer, and learns which devices are on which side, filtering traffic so data only travels across the bridge when necessary, making the network more efficient and secure. Bridges can be hardware devices or software, like in operating systems, and are used to link wired networks, extend wireless to wired devices, or connect distant networks wirelessly. Key functions and features: connects network segments. A bridge physically or virtually links different segments of a local area network, LAN. Intelligent traffic management. Unlike a hub, which simply broadcasts all traffic to all ports, a bridge learns the MAC addresses of the devices on each connected segment and builds a forwarding table. This allows it to forward frames only to the necessary segment. Reduces collisions and congestion, by filtering local traffic, preventing it from crossing the bridge if the destination is on the same segment as the source, and creating separate collision domains. Bridges reduce unnecessary network traffic and improve overall network performance. Transparent operation. Bridges operate transparently to end devices, meaning computers or other network devices do not need any special configuration or drivers to work with the bridge. Extends network reach. Bridges can connect network segments across distances longer than a single Ethernet cable segment would normally allow, or can connect different types of physical media, example wired and wireless networks. Loop prevention. To prevent network loops, which can cause broadcast storms, bridges implement the spanning tree protocol, STP, to create a loop-free logical topology. Modern relevance. Bridges versus switches. In modern networking, the term bridge is often used interchangeably with switch, as a multi-port switch is essentially an advanced, hardware-based multi-port bridge. Switches are much faster than traditional software-based bridges because they use specialized hardware, ASICs, for forwarding decisions and can handle many more ports. While dedicated two-port bridge hardware is less common today, the concept of bridging is widely used. Wireless bridging. Many wireless access points and routers can be configured to act as a wireless bridge, connecting a wired network to a wireless one or linking two distant wired networks wirelessly. Software bridging. Operating systems like Windows and Linux allow users to create software bridges to combine multiple physical or virtual network interfaces on a single machine. Router bridge mode. A common home use is putting a secondary router into bridge mode to disable its routing functions, like DHCP and NAT, and turn it into a simple access point or switch, extending the primary network's coverage. The Ethernet bridging process involves three core actions: learning, filtering, and forwarding frames based on media access control, MAC, addresses. This process is transparent to the end devices on the network, which operate as if they are on a single network segment. The bridging process. Here are the step-by-step operations a bridge performs upon receiving an Ethernet frame. 1. Learning, building the MAC address table. Receive frame. The bridge receives an Ethernet frame on one of its ports. Inspect source MAC. It examines the source MAC address in the frame's header to determine which device sent the frame. Update table. The bridge records the source MAC address and the specific port number where it was received in its internal memory, known as the forwarding table or content addressable memory, CAM, table. Aging. Entries in the table include a timestamp and are periodically removed, aged out, if no traffic is received from that address for a set period, typically a few minutes, ensuring the table stays current if devices move or disconnect. 2. Filtering or forwarding, making a decision. After learning the source's location, the bridge uses the destination MAC address and its forwarding table to decide how to handle the frame. Filtering. If the destination is on the same port as the source, the frame is dropped. Forwarding. If the destination is associated with a different port in the table, the frame is sent only out that port. Flooding. If the destination is unknown or it's a broadcast/multicast address, the frame is sent out all ports except the one it arrived on. A response will help the bridge learn the destination's location for future frames. 3. Loop prevention. Spanning tree protocol. Redundant links can create loops, causing network issues like broadcast storms. The spanning tree protocol, STP, is used to prevent this. STP operation. STP enables bridges to establish a loop-free network topology by exchanging bridge protocol data units, BPDUs. Port states. STP blocks redundant ports, ensuring only one active path exists between network segments. If an active link fails, STP can reactivate a blocked port. Example of bridging process. Consider a simple network with a bridge connecting two segments, LAN A, port 1, and LAN B, port 2. Host A has MAC, A1 host B has MAC, B2 host C has MAC, C3. The bridge's MAC address table starts empty, MAC port address, empty, empty. Step 1, learning, host A sends a frame to host B1. Action, host A, A1, sends a frame destined for host B, B2. 2. Bridge receives, the bridge receives the frame on port 1. 3. Learning, the bridge inspects the source MAC address, A1, and adds an entry to its table. 4. Forwarding, flooding the destination MAC, B2, is not in the table. The bridge floods the frame out of all other ports, only port 2 in this case. 5. Result, host B and host C receive the frame. Host C discards it as the destination MAC is not its own. Host B accepts it. MAC address table after step 1, MAC port address A1 port 1 step 2, learning, host B replies to host A1. Action, host B, B2, sends a reply frame destined for host A, A1. 2. Bridge receives, the bridge receives the frame on port 2. 3. Learning, the bridge inspects the source MAC address, B2, and adds an entry to its table. 4. Forwarding, filtering, the bridge looks up the destination MAC, A1, in its table and finds it is associated with port 1. It forwards the frame only to port 1. 5. Result, only host A receives the frame. MAC address table after step 2, MAC port address A1 port 1 B2 port 2. Step 3, filtering, host A sends another frame to host B1. Action, host A, A1, sends another frame destined for host B, B2. 2. Bridge receives, the bridge receives the frame on port 1. 3. Filtering, the bridge looks up the destination MAC, B2, and confirms it is on port 2. It also knows the source, A1, is on port 1. 4. Result, the bridge forwards the frame directly to port 2. It does not flood it, because it knows exactly where the destination is. Through this process, the bridge intelligently manages traffic, reducing unnecessary network congestion and building a complete map of the connected devices over time.